Right, so today we're going to be discussing contest problem, uh, team problem 8 from contest 12205. So this is the from last school year. I guess we'll start with what the problem is. So for a real number r, we define what the fractional part is, which is r minus the floor of r, basically. And then we define the fullness of r to be essentially some function on the fractional part of r. And then here we have a few examples. And then we define g of r to be the inverse of f of r when f is defined over the interval from 0 to 1. So now we want to find the smallest positive integer k that satisfies this last inequality. So I guess we want to figure out how to approach this problem. So I guess to start, we want to try to understand f. So, well, how we do that is, well, if r is on the interval from 0 to 1, which is the interval that we're defining f over, then we have that the floor of r is just 0. So this is quite useful to us because then the fractional part of r is just r because it's r minus the floor of r, which is 0. So then when we plug that in, f of r is just r over 1 minus r. So that's this is like a lot easier to deal with. We don't have any like fractional parts or floors or anything like that. It's just a regular expression. Now we want to sort of understand g a bit better. And so g, the range of g is the domain of f because they're inverses. And the domain of f that we're taking over is when f is between 0 and 1. So that's going to be what the range of g is. So we know that f of g of r has to equal r because they're inverses. And so what happens is we plug in g of r, and g of r we know is in the interval from 0 to 1. And so f of that has to satisfy the expression that we found. So it ends up being g of r over 1 minus g of r. And that ends up equaling r. So now we have a convenient equation between r and g of r. So all we have to do is move everything to like remove fractions basically, move all of the g of r's to one side and everything else to the other side and solve for g of r. So we got this nice expression for g of r. And so now our next step is to basically solve the problem, right? Because if we remember what we want to do, we want to find the least k for which g of k plus 1 minus g of k is less than 1 over 2020, right? Now we already know what g is, so we just can plug everything in. And now we like remove common denominators and we got basically almost everything cancels and we're left with 1 over k plus 1 times k plus 2 is less than 1 over 2022. So we take reciprocals of both sides, and if we're taking reciprocals, and both sides are positive, we just assign. And well, now we want to find the minimal k. And the minimal k we can just find because essentially 2022 is close to 45 squared, which is 2025. So then we can put it between 44 times 45 and 45 times 46. And so 45 times 46 ends up giving k equals 44, and that's our answer. So we're done.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.